This presentation will provide an introduction and basic understanding of the Common Industrial Data Model, also known as CIDM. The CIDM represents a crucial element of the Cross-CPP ecosystem, enabling a brand-independent data exchange between big data providers and data consumers. First of all, what is the Cross-CPP ecosystem about? The vision of the Cross-CPP ecosystem is to create access by the outside world to the huge amount of sensor data coming from high-volume products of various industrial sectors, such as vehicles or smart buildings, opening a new dimension of business opportunities. The Cross-CPP ecosystem is developed in the scope of the Cross-CPP project funded by the European Commission in the scope of the H2020 Research Initiative. With the increasing number of connected sensors and actuators within cyber-physical mass products, there is an enormous amount of data continuously generated by the data provider. The Cross-CPP ecosystem handles such big data volumes of cyber-physical products representing a digital model of the world, stored in the cloud. Companies, such as Volkswagen with their cars or Siemens with smart buildings, represent such data providers. From a data consumer point of view, the Cross-CPP ecosystem enables the access to the data of the model of the world. This opens new dimensions of business opportunities for many stakeholders, such as startups, cross-sectorial industries and suppliers, etc. Based on these data, such data consumers may improve existing services or create new ones for their customers. For these data consumers, the Cross-CPP ecosystem represents a one-stop shop, the single point of access to data streams from the multiple mass products. However, these major big data-driven business potentials are still locked, since the current situation on CPP manufacturer side as data provider is characterized by our proprietary limited CPP data access and brand-specific data formats, mostly restricted to be used by CPP manufacturer-specific products and services. A data access by data consumers would require CPP manufacturer-specific data interfaces, which is by far too complex and economically inefficient. To enable an easy access to the data of diverse CPP manufacturers from a data consumer point of view, a brand-independent representation of CPP data would be required, enabling a single access point with just one interface. Such features would boost the business potentials and create a win-win value chain for all CPP ecosystem partners. The question is, how to bridge this gap? The actual gap between data provider and data consumer can be bridged by the introduction of the Common Industrial Data Model, CIDM, as one common standard for all kind of CPP data. By such approach, it is possible to overcome the actual data access constraints. The CIDM is an open and highly scalable big data format, designed to transform proprietary CPP data into brand-independent datasets. Furthermore, the CIDM is open for the integration of diverse CPP data, supports different signal and measurement types and provides data ownership information. The brand-independent CPP data are stored in the cloud and the Cross-CPP ecosystem, as a one-stop shop, enabling data consumer to have access to these data. For the CIDM, a layered data model architecture was selected, convenient to satisfy the stated data consumer requirements for data provision. The three layers represent the signals as information providers, the measurement channels as the recording of the measurement configuration of those signals, and the data packages providing a structure for storing and retrieving data. On the signal layer, the CIDM signals provide observations, raw sensors measurements and status information of an individual CPP. Thereby, the signals may vary between different brands, models or even for CPPs of the same model by value range, sampling rate and resolution. Furthermore, different types of signals are supported such as text, like CPP type, numeric, like temperature, or enumeration, like fuel type. The data format enables to define various signal types and other characteristics of the signals. To minimize the amount of data exchanged and stored, the data contained in signals are aggregated and pre-processed, represented by so-called measurement channels. By various measurement channels, the CIDM supports different data representations tailored to the needs of the data consumer community. Typical measurement channels are: time series channel, representing geo-referenced sequences of recorded data with a constant sampling rate or based on events. Histogram channels, providing a one- or multi-dimensional distribution of sampled sensor data. Geo-based histograms, enriching the histogram approach by a geospatial dimension. On the data package layer, several measurement channels are aggregated in data packages to be stored and retrieved. The CIDM data package is divided into two parts: the descriptive metadata and the aggregated data. The metadata cover information like ownership, privacy levels and data stakeholder, etc. Furthermore, metadata support indexing, sorting of data and quality assessment. The second part of data packages stores aggregated data of measurement channels. The presented CIDM standard is not rigid, but rather representing a living standard, whenever required in reference to market needs of the data consumer community. The amount of recorded signals or modification, respectively extension type of measurement channels covered by the CIDM standard can be adapted. A respective standardization board composed by the key shareholders of the Cross-CPP ecosystem will decide about any modifications of the CIDM. If you got interested or want to learn more about the Cross-CPP project, check out our website or visit us on Twitter and LinkedIn.